Hi, I'm Dick, and this is my friend Niles.
Hi.
And we're here today to give you a tour of our recently completed Southern Pacific Donner Pass layout. Well, before we start running trains, it probably makes sense to talk about the history of this layout, how it was created, and how long it took to build. The origins of this layout were in 1998. We had recently moved up here from the Bay Area, and I knew right away, as soon as I saw the Roseville yard and the Donner Pass, that I wanted to model the Donner Pass for this layout. The main line of this layout is 600 feet long, and it's a dual track main line that runs from Roseville, California, all the way over to Sparks, Nevada. The main yard of Roseville and Sparks are shared yards due to space constraints, and the hidden yards of Ogden and Oakland Mole are also shared, and that sharing allows a unique feature of this layout which provides auto staging. So trains that pull into Ogden that are going eastbound are magically transported all the way back to Oakland. So that means trains that are going westbound always go westbound, and trains that are going eastbound always go eastbound. The building is 45 feet by 45 feet, and the layout itself is constructed in a 45 by 34 foot footprint. The trackage ranges from an elevation in the center yard of 50 inches off the floor all the way up to 78 inches, which you can see in this scene right here with the bridges that go over the entryway to the main yard. The back of the room has an elevated walkway that provides for two towns that cannot be seen from the center of the room. Both Blue Canyon and Emigrant Gap are completely hidden and are accessed by this walkway around the back of the room. The CAD drawing of this layout can be seen in this slide. It's a three-dimensional slide. It has track elevations on it, and the 600-foot main line has to loop back on itself to gain enough elevation for this walk-under bridge that is seen in this scene. It takes a lot of trackage to get all the way up to this altitude because we only have a 1.5% ruling grade on this layout. The benchwork and roadbed construction were somewhat different from this layout than other layouts. The layout uses L-girder benchwork and has, as I mentioned, a 1.5% ruling grade and a minimum of a 48-inch radius curvature on all mainline trackage. The track support uses risers and hurricane ties that connect to a spline that is 11 layers thick for each track. The spline is 2 inches high, and you can physically walk on the spline, and both Niles and I over the years have walked on it and sat on the spline ourselves. The main yard and hidden yard are built on 3/4 inch plywood that's been planed, and then homosote has been put on top for the roadbed itself. The main line is also homosote, and the track was put on by push pins and white glue. The track work for this layout is Walters Code 83. And the turnouts were all put down by spikes, whereas the track itself was glued down with white glue. All the track joints were soldered, and there are power drops every 6 feet. And on the main line, there are 19 separate electrical occupancy blocks. The track block length is 15 feet to 40 feet. On this slide, you see the main yard in the state of where the track is being put down. We did something unique in the main yard, and that is the CAD drawing was printed at 1x scale. And by printing it at 1x scale, we were able to transfer the image of the yard directly onto the homosode. So when it came to putting the trackage down, you can see the white lines that are on the homosode and made it very, very easy to place the turnouts and the trackage in the main yard. Now we'll talk about the bridge work. There are 30 bridges on this layout, and they vary from brass, hydrocal, and plastic. Some of them are as short as 1 foot, and some of them are like the bridges you're looking at here that are 10 feet long. The bridges are of 3 different types. They're arch bridges, truss bridges, and girder bridges on this layout. We made the bridge abutments separate, and you can see they're clamped here with a clamp so that you can raise and lower the bridge abutment to ensure the planar trackage on top of it. The electronics are very unique. We have a computer station over in the corner that runs Railroad and Company train controller. This electronics handles both the running of the trains, the controlling of the turnouts, and the signals, and also detects occupancy. There are 12 touch screens that display and control the signals and turnouts and sense the occupancy. There are over 100 electrical blocks on this layout, 180 signals, and 150 turnouts. The DCC electronics is North Coast, and the electronics for actuating the signals and turnouts and sensing the occupancy is made by CTI. Both of these are connected to the computer and are run by Railroad and Company train controller software. There are 12 touch screens located around the room that display the turnout states, the signal states, and the occupancy states. Each block on the layout where occupancy is sensed not only senses that the block is occupied or not, but also displays the engine number as it moves around the layout. So the dispatcher and the yardmaster never have to question what train is where, because they can just look at the touchscreen and see what engine is in that particular block. Each of these touchscreens have on them the entire main line if they're displaying the main line, and you can see all the signals, all the turnout states, and the occupancy on the main line. Similarly, the yard has not only the main yard, but the hidden yards on it. And again, all the turnout signal states and occupancy are displayed on these 12 touch screens. The yardmaster and the dispatcher control routes and can set turnouts at a single touch on their touch screens. Now we're going to talk about our throttles. The throttles are cell phone throttles, ordinary cell phones that are cheap. These are $30 cell phones, a lot cheaper than what you can get from North Coast or Digitrax for their throttles, and they have touch features that are so easy to use. Let's look at the throttle itself. You can see the throttle on the top bar has the Wi-Fi strength and the local time, the actual time. But a little bit further down, you have the engine number and you have the fast time. But probably what is more unique is the engine speed and the odometer. Both of these are calibrated to scale. So when you see 20 miles per hour, the train is actually going a scale 20 miles an hour. Now, why would this be important? If you're doing a helper operation, you've got to match your helper speed to your head end speed. And this allows you to do it. Both can be set at 20 miles an hour and they actually match each other. The train doesn't have any buckling problems. The next bar down, you can see an arrow that controls the engine speed, and then you have an up and down arrow that control whether you're going to increase the speed or slow down the engine. Something else that's unique about Railroad and Company is the train controller software allows you to see the capacity of the resources in the engine, how much water capacity you have and how much oil you have. Railroad company even goes to the extent that if you run out of one of these, your engine will stop on the layout. We don't actuate that feature, but it is available. And on the bottom of the throttle, you have the functions. The functions are pictures, so it's very easy for an operator to know what they're doing. The headlight icon is a headlight. The number board icon is a number board. And the bell, when you hit it, guess what? The horn, you have two horns on this particular engine. You have the main horn and the secondary horn. And then you have an engine button that shuts down and starts up the engine. You have a volume to control the volume of the engine sounds. And then you have various other functions, couplers and smoke, that again are all controlled at a touch. Now let's spend a moment to talk about under the hood, the DCC electronics and the wiring. There is one North Coast Engineering control station with 12 boosters scattered around the room to power the engines on the track. There are 70 PSX circuit breakers to localize any shorts that occur on the main line or the hidden yard and main yard. There are 35 CTI modules to control the signals, the turnouts, and sense occupancy. All the wiring for the main line is 12 gauge wire, and there are power drops every 6 feet on the main line. The portion of the construction of this layout that most people care about is the scenery. And almost all of that was done in the last year. We were taught how to do scenery by Dave Frary, Bob Hayden, and Scott Mason back in 2008 when they built the mountain just to the left of this scene. They spent 1 week building it, and Niles and I learned how to do scenery while they were here. The rest of the scenery was completed in 10 months in 2020 during the COVID shutdown. And there are over 7,000 trees that were planted. Multiple rock faces had to be painted and positioned and put in place. And on top of that, there are tons and tons of tunnels, along with tunnel linings and track safety barriers put in the tunnels. So let's take a couple moments now to talk about train operations. Train operations on this layout run to a schedule in 1948. So there are arrival times and departure times that all the trains except for the waif rates must follow. The waif rates are scheduled by car cards and travel around the layout avoiding the scheduled trains. During operations, all of the turnouts and routes are controlled by the dispatcher on the main line and the yardmaster in the hidden and main yards. Communications between the operators and the yardmaster and dispatcher are done by radio, and signaling is paramount. Most of the layout is covered under tunnels, so there is an absolute essential nature to the signaling on this layout. The signaling follows CTC standards, which are pretty standard for everyone, which is green, proceed, yellow, proceed with caution, prepare to stop, and red, absolute stop. Okay, now let's run some trains. As yardmaster, I'm going to set the route for the first train of the day, which is fruit block train number 490. So the first thing I do is I look at the track that the train is on, which is hidden yard track A, and I set the route exiting the hidden yard. Then I have to cross over to the correct main line to enter the yard, and then I have to set the train so it'll go to the icing station. So the route has now been set for fruit block train number 490, exiting the hidden yard at Oakland on track A, going to the main line, then crossing over to the eastbound main line, and then entering icing station at Roseville. Now that the fruit block with all the reefers have been iced, it's ready to go up the mountain. Here the train is entering the main line through the Auburn Cut and transiting Niles Canyon. This is not the Niles Canyon located in the Bay Area. This is Niles Canyon, named after my friend Niles for all the work that he's done on this layout. Since this is a Donner Pass run, there are all kinds of mountain tunnels strung along the layout, and you only see the trains when they're daylighted between tunnels. The fruit block is now approaching Colfax. At Colfax, it will enter the siding so the first-class mail train can pass it going up the mountain. Mail train number 22 is now approaching Colfax and will pass the fruit block on the main line.
All full.
So fruit blocks historically had helpers cut in at Colfax to help push them up the grade to Norden. The trains were so heavy and they were typically 100 cars long that they required a helper to be added to the train. As you see here, the train is being pulled forward, the caboose is uncoupled from the train, and the train is then pulled forward, clearing the siding for the helper to come out from the turntable and hook on to the caboose. Once it's hooked onto the caboose, it pulls forward to reconnect with the train so that the train can navigate its way up to Norden. We'll now leave the fruit block and go all the way over the mountain to Sparks to watch the Overland enter Sparks and go up the mountain to meet the fruit block at Norden. The Overland is now navigating the S-curve in the Truckee River Canyon. The Overland is now approaching and crossing Donner Peak. Notice the China Wall and the snow sheds. The fruit block is now crossing 2 truss bridges at toll before it goes through the tunnel and goes to the back side of the layout. Now we're on the back side of the layout and the fruit block is entering Blue Canyon. The fruit block is now transiting the entire length of the back room and is now approaching Emigrant Gap in the other corner of the layout. Now the fruit block is leaving Emigrant Gap and going across an arch bridge before it approaches Norden. The fruit block is now approaching what is considered the most unique feature of this layout, which is an arch bridge that's 7 feet off the floor, and this arch bridge views the entire center of the layout and also connects to the town of Norden. The fruit block has now reached Norden. At Norden, the helper is cut out, goes through a turntable such that it can go back down the mountain on the westbound main. This concludes our layout tour of the Donner Pass run. We thank you for watching, and we really appreciate your support. We look forward to many years of fun operations and weathering and other such fun tasks. Have a great day.